Hi everybody, my name is Mike Hoskins and I'm the CTO of Pervasive Software. And on behalf of Pervasive, I would like to welcome you to SuperComputing 08. This is the biggest supercomputing event of the year. And this year, the 20th anniversary year, it's being hosted in Austin, Texas, our hometown. And so Pervasive Software took this opportunity to roll out some of our new, most advanced research around parallel programming here at SuperComputing 08 in Austin. So you're going to be with me for a couple of minutes. I'd like to share with you 4 different items that I think are quite interesting that we're showing in the booth today. First, let's go over here and look at DataRush. This is really the main point of our booth here at SuperComputing 08. One of the biggest problems that people face in the software industry right now is how to develop the next generation of massively parallel software. So we've decided to contribute to the solution of this problem by offering to the world DataRush, a highly scalable framework for developing data-intensive applications on multi-core. So that's a mouthful. What does it mean? The world of HPC has traditionally worried about sometimes fairly small or modest data volumes. So they're able to load it into memory, work on it with their matrix math and their Fortran programs. That world is changing. That entire landscape is changing right in front of us. And data-intensive HPC means we now have to deal with vastly larger and exploding data volumes. This is a problem where the old architectures are not going to scale. We call this data-intensive HPC, DI-HPC. For this kind of world, you need a new generation of software that can exploit the commodity multi-core hardware revolution. And so that's what DataRush is. It's a developer platform to allow developers who don't need to be parallel programming superstars to develop massively parallel data-intensive applications that they can then develop on commodity boxes that we're going to look at in a minute. Now, DataRush itself is built on a data flow architecture. This is a well-established architecture in science that allows us to scale very elegantly for very large data volumes without having to expand the memory footprint. And so the key principles of data-intensive high-performance computing are that you have to scale for data volumes. We can scale for any data volume. You have to scale for the emerging world of hardware hyperparallelism. How can you deal with a world where there's hundreds of cores and thousands of threads? DataRush does that very elegantly. How do you scale for cognitive load? How do you scale for the fact that programmers can't cope with parallel programming? DataRush hides the complexities of parallelism, so you don't have to worry about deadlocks or memory management or multi-threading. All of that is done for you by DataRush. And finally, we scale for economics, because you can run all this in amazingly powerful commodity SMP workstations. And you know what? Every 12 months, these workstations are going to fall in price by 50%. And so you're going to have infinite and inexpensive hardware threads to run your DataRush massively parallel applications on. Well, let's take a look at that kind of hardware as an example, what the future of commodity supercomputing can be. This is a box we're showing here. We call it a personal supercomputer. This box down at the bottom has in it 32 64-bit Opteron cores. Each core can do 10 billion instructions a second. That's 160 billion instructions in a commodity box. We have 64 gigabytes of RAM in there. RAM is getting free. It could have been 128 gig. We have 12 terabytes of hard disk in there. We could have made it 24 terabytes. You can go down to Fry's and buy a terabyte for $100. And so that entire box, that personal supercomputer, is maybe $15,000. And you know what? Next year it's going to be $10,000, and then it's going to be $7,000. And for $15,000, you'll be able to buy a box that's 10x bigger. And you know what? It's going to be an SMP box. And so a single address space, easy administration, easy maintenance, easy programming model. And that's the kind of supercomputer that we have targeted with DataRush. And so you can take the magic of DataRush, being able to build massively parallel, fine-grained, multi-threaded applications to crunch lots of data, and then you can run it on this incredibly inexpensive commodity hardware. So what could you do with that as a sample application? So you've got DataRush as a developer framework. You've got commodity hardware that you could run it on. What are the big applications that we could use? So let's go over to this side of the booth over here. You'll see an example of an application that we have developed. We're going to submit it to KDD 2009. That's the #1 data mining show in the world. And so we think DataRush is appropriate for lots of application spaces, but one of them would be data mining. And so what is a data mining problem? It's how do you crunch through a lot of data to look for patterns. And what we chose as a data set, because it's known to the world, is the Netflix data set. So there's a very popular competition called the Netflix Prize, where they gave you very large data sets, 100 million movie reviews running across 480,000 users, up to 200 reviews per user on 17,770 movies. So that's the Netflix data set. A traditional way find patterns in your data is to do what's called clustering. And K-means is a very popular clustering algorithm. So in collaboration with the University of Texas and some of their top data mining professors, we have decided to try and build a massively parallel implementation of K-means clustering with K equal to 30, so 30 centroids, across the entire Netflix data set. And here you see the early results of that project. We're only going to submit the paper in January and show it in 2009, but already we're achieving on our commodity 16 and 32 core machines linear scaling and runtimes down in the seconds for data sets that are 5 and 10% of the total data set. So keep your eye on us. I think we will be able to, with this initial K-means and eventually co-clustering, we'll be able to run across the entire Netflix data set in a matter of seconds. And that's something that nobody else in the world is able to achieve. So that's an example of a massively parallel data-intensive DataRush application in the data mining space. Could you go further? Yeah, let's go over here and take a look at what I think is an interesting example of where pervasive research is going and where I think the marketplace would like to go. Not everybody is a parallel programming superstar, but everybody wants the benefits of parallels and they want to crunch this much data in this much time. And a nice way to do that would be to develop a higher-end user interface so that practitioners of the science could get parallel data mining without having to do parallel data programming. And so we're exploring, and this is very early days, using a graphical interface to do high-end data mining visualizations, and then gluing into the framework of that user interface the vast power of DataRush horsepower. And so you can crunch enormous amounts of data, but you get to implement that data within a user-friendly data mining application. So that's it for today. You've had a little snapshot of what we're all about here at Pervasive and the DataRush team. We're giving you a highly scalable framework for developing massively parallel data-intensive applications on multi-core. Here's an example of the amazing amount of commodity horsepower you get in S&P workstations. You've seen a data mining application over there with K-means co-clustering on 30 centroids, and now even a glimpse into the beautiful future of what we could hope to do with bringing data mining to the practitioners out there in a much more powerful, especially price performance way. So thanks again. Hope you get a chance if you're in Austin to visit us at Pervasive DataRush booth number 203. And if you don't, go to pervasivedatrush.com and download and play away. Good luck. Thank you.